Hello. This presentation looks at how to model the potential for forest loss and REDD+ projects in Brazil by using the GeoMod module inside the TerrSet software. This project was done as part of Professor Robert Gilmore Pontius's GIS and Land Change Models course at Clark University. We analyzed forest loss trends within 3 states in the Amazon Basin region: Amazonas, Acre, and Rondônia. These areas were chosen based on the division of a larger course project. For our model, we investigated how the length of calibration and validation intervals affect the figure of merit, the number that qualifies an area to be considered for a REDD+ project. When calibrating the model, we considered different variables that affect forest loss. But given that human-caused forest loss is prominent, we also compared the effect of considering anthropogenic land uses versus non-forest land cover in the model.
These 2 maps show the data used in our analysis. The map on the left displays forest loss between 2000 and 2020, categorized by year, while the map on the right displays forest and non-forest categories in 2010, which was the starting point for all of our model runs. This is our suitability map using distance from non-forest in 2010, which displays area where forest loss may be most likely. Notice that higher values indicate a higher suitability from forest loss and not actual distance. These are 6 additional driver maps used in our analysis to find areas of likely forest loss. This includes elevation, population density, protection status, land forms, land cover, and recognized indigenous territories. This is our suitability map that we used for our anthropogenic land proximity runs, which uses distance from anthropogenic land uses in 2010. This was used with the intent of increasing the accuracy in finding areas where forest loss may not be likely. Notice that water land cover was masked out since it's not a candidate for forest loss. In GeoMod, the following parameters listed were used for this analysis. When creating the suitability driver maps, we tested 3 different runs for each time interval: a proximity run, which uses distance to non-forest as suitability, a multivariate run, which uses the other driver maps previously mentioned, and lastly, an anthropogenic run, which uses distance to anthropogenic land use. This is a total of 30 model runs, 3 for each time interval, with intervals ranging from 1 year through to 10 years.
These charts display the change in forest loss across our calibration period, shown in orange, and our validation period, shown in purple. In the left chart, forest persistence decreases over time, indicating a complementary increase in forest loss, shown in the right chart. The qualifying figure of merit for each time period is noted for each calibration year near the bottom. The results of our 30 model runs are compared here and decomposed into the number of hits, misses, and false alarms, calculated from each validation interval. Along the x-axis, you can see for each validation time interval over 10 years the validation of the proximity run, the multivariate run, and the anthropogenic land proximity run. At the bottom of each bar, you can also see that each run has a figure of merit that meets the voluntary carbon standard threshold to qualify for a REDD project. For each time interval, you can see that the anthropogenic land proximity run has more hits and a higher figure of merit than both the proximity and the multivariate model runs. Our results indicate that models with longer calibration intervals that consider multiple variables, including distance from anthropogenic land use, have the potential to increase the figure of merit. We also found that solely using the distance to non-forest as a driver map discounted the effects of other land cover categories, such as water and rivers. And because of the rate of forest loss can differ between geographies, we suggest models for other areas to tailor their own suitability maps. And in conclusion, our models all resulted in a qualifying figure of merit regardless of the time interval or suitability variables considered.